Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim Ashraf bin Mazlan. Okay, today I want to present about the introduction of this heat transfer assignment. Okay, first thing first, we go through the conduction of heat transfer definition. Okay, the definition of conduction heat transfer is the transfer of heat by means of molecular excitement within a material without bulk motion of the matter. The conduction heat transfer in gases and liquids is due to the collision and diffusion of the molecules during their random motion, while heat transfer in solid is due to the combination of lattice vibration of the molecule and the energy transport by free electron. The conduction also the transfer energy from the more energetic to less energetic particle of a substance due to interaction between the particle. In addition, conduction on heat transfer use Fourier's law. The Fourier's law states that the heat transfer rate through a material is proportional to the negative gradient in the temperature and to the area, at right angle to that gradient, through which the heat flows. The formula of conduction heat transfer is Q conduction equals negative K. K is meant by coefficient of conduction. A is meant by area. dt is delta T, the temperature difference, over delta X. Delta X is meant by thickness of the material. From this assignment, the aim of the investigation is we should be able to perform heat transfer simulation process using any suitable software on fine surface. Okay, next, what we have is the dimension of heatsink number 1, as you can see from the slide above.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzad Izzuddin bin Hanafi. My MacBook number B0918100329. Today I will take over material for heatsink 1. Heatsink 1 divided by two components, which is the base and the fin. Heatsink 1 properties is using 6061 alloy. The model type is a linear elastic isotropic. Heatsink 1 default failure citrion is unknown. Thermal conductivity for 6061 alloy is 170 watt. The specific heat is 1300 joule kilogram Kelvin, and the mass density is 2700 kilogram meter cube. Next, I will cover about thermal load for heatsink 1. The thermal load for heatsink 1 divided by two types of load, which is convection and heat power. For the convection load, is covered by 504 phases of entities, which is like the whole drawing, and convection coefficient is 40 watt, and the time and temperature variation is off, and the bulk ambient temperature is 303 Kelvin. For the heat power load, which is only one phases of entities at the base, at the face of the base of our drawing, and the heat power value is 65 watt.
Hello, Assalamualaikum. My name is Muhammad Ashraf bin Zulkifli. In this slide, we can see the result for the final result for the heatsink 1. As we can see, the minimum temperature for the heatsink 1 is 89.221 degrees Celsius, and the max temperature for the heatsink 1 is 101.318 degrees Celsius. The minimum note for the heatsink 1 is 730, and the maximum note for the heatsink 1 is 21,865. Okay, and for the next slide, In this slide, we can see the dimension for the heatsink 2.
My name is Ahmad Shahir bin Ismail. Okay, I will continue on the material of heatsink 2, which is, as you can see, the model reference here. Okay, for the properties we use is C061 alloy, okay, which is consists of model type of linear elastic isotropic, and thermal conductivity is 170 watt meter Kelvin. Okay, for the specific heat is 1000 is 300 joule kilogram Kelvin. Okay, for the mass density is 2700 kilogram per meter cube. Okay, for the component is we divide by 2, which is component 1 base and component 2 fin. Okay, next we go to the thermal load heatsink 2. Okay, for the load name of heat power 1, the entities we use only one phase. The heat power value we use is 65 watt. We apply this power value at the bottom of the heatsink, bottom surface of the heatsink. Okay, for the load name of convection 1, the entities is 63 phase. The convection coefficient is 40 watt meter cube Kelvin. Okay, the convection coefficient we apply to all of the surface except the bottom of the surface heatsink. Okay, the ambient temperature is 303 Kelvin, which is surrounding temperature.
Assalamualaikum and hi everyone. My name is Muhammad Razik Afiq bin Anwar. So we shall continue with the study result for heatsink 2. As we can see here, the maximum temperature for heatsink 2 is 82.267 Celsius with the knot 694, while the maximum temperature for this heatsink 2 is 93.145 Celsius with the knot 17,668. So as a conclusion, we have identified the difference between maximum and minimum temperature value for both heatsink 1 and heatsink 2. So the difference for heatsink 1 is 12.097 and heatsink 2 is 10.878. The greatest different value of temperature has more efficiency. So as a conclusion, heatsink 1 is more efficient than heatsink 2. So that's all from us. Thank you.